Okay.
Okay. Are you in the quiz?
Yeah.
Okay. So question 3, human blood types have been classified into one basic types, O, AB, and AB, the proportion of people in the population of the United States. With each of these blood types is summarized in the following table. The blood types and proportions given in the table above define a probability distribution. True or false?
I think I would say true, because don't they all add up to like 100 or 1?
Hold on, let me fix my computer. So 0.85. Okay. Question 4.
So that one is, what is the probability that a randomly selected person in the United States has type O blood? So wouldn't it just be 0.45? Or yeah.
Yeah, I think so. It says give all your probability as decimals. Okay, so 0.45.
Okay. And then what is the probability that it is not O blood? That would just be
So 1 minus. It's just 0.55.
yeah.
Okay, Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer, and 1 sample came from a person identified as a bladder cancer patient. If the dogs guess at random, what's the probability that will correctly identify the dish containing the bladder cancer patient?
So
Round to 3 decimals.
Like 1 divided by 7, which that is.
Yeah, because it's 1 out of 7.
Yeah.
So 0.143.
Yeah.
Is that what you get?
Yep. Okay. So in a combined total of 54 trials, the dogs correctly identified the specimen of the cancer patient 22 times. What is the? Is that very? That's. Is it very unlikely that the dogs would do this well by random chance alone? Which of the following statements must be appropriate? So this provides strong evidence that the dogs can detect, or little evidence that it can detect. So
Isn't it little?
Well, if you divide it, so it's like 0.40, something like that. So would that be enough? Because if it was just randomly, it would have been like 7 times. So it's definitely a lot more than just totally random, but it's definitely a lot.
I would say, because it's definitely a little evidence, don't you think? I mean, it's not halfway or above.
True. Yeah, we'll just go with that one. And if we're wrong, I guess we can take it again.
Do you think that, or would you have put the strong evidence?
It can go either way, but it is not even half, so I'm just going to put a little.
Okay. M&Ms are small chocolate candies, and indicated in the United States the distribution of colors in a bag of plain M&M in the following table. If you reach into grams, what is the probability of drawing a red?
So it'd just be 0.13.
How are the greens scratched out?
Well, I think we're supposed to find it.
Oh. Okay. I think it's just 0.13.
Yeah. So what is the probability?
Probably.
That you
So I got 0.16.
Oh, wait, what? Oh yeah, 1/6, because you had to add them all up and then subtract by 1.
Yeah.
So 0.16 is our answer. Okay. Now it's if we don't get a green, will that just be 0.84?
Or, yeah.
Yep. So the ACT score, or I guess ACT score, of students admitted to a medium-sized public university in the Western United States was taken from CapX.com. The following summary takes the instruction. Yeah. So half the observed are less than or equal to what number? Wouldn't that be the median?
Yes. Right?
That'd be 24. Yeah, because the median's the middle number. The mean is kind of the average. So
Yeah, means the average. So half of the observations are less.
yeah, it'd be 24. Hello.
So you got 24 for the last one? Okay.
Yeah.
Based on the information on the table above, the top 25% of students scored above what number? So above 27?
Yeah, because Q3 is the 75 percentile.
So the top 25 would be above 27, right? Okay.
Yeah. Okay. Now, what is the following statement? That is not one of the 3 rules of probability. So, would it be if the probability is high, then the probability is positive, and if the probability is low, the probability is negative?
Yep, that's what I'd say.
Okay, so.
Okay, let's submit this sucker.
No, we missed one.
What did we miss?
Oh, yeah, so the strong evidence one.
Okay, do you want to retake it?
Yeah, 1 second.
You have class.
Okay, we'll just retake it. Okay. So that's true, true, Okay. That was true. So the probability of O is just what the number was, so it was 0.4.
Okay, so it was
Yeah.
0.45, was it?
Yeah, 0.45, and then the next one would be 0.55.
Okay, and then it was 0.143. Is that what it was for the question 6?
Yeah, I think so.
0.143. Yep.
0.143.
Okay, and then it was that it provides strong evidence. And then
0.13.
0.13. 0.16.
This one would just be 0.84, right?
Yeah, I'm just double checking to make sure they're all the same. Okay, yeah. 0.16, and then 10 is 0.84. And then 11 was the median, so 24.
Next one was 27. And then the last one was the probability of high.
So the probability is high when positive. Okay. Take 2.
Okay, got 100%.
Sweet. Okay, well, that was good. That worked out a lot better than last week.
Yeah, last week was retarded.
Yeah.
Were you ever able to actually do it?
I never could get the files to open, and then by the time I figured out how to do it, the thing was closed.
No.
So I'm gonna email her and ask her if she'll open it back up for me.
Yeah, because mine, like because I use the VMware or whatever it's called, and you can open everything from there, but when you actually do the video at the same time, there's no technically microphone for you to use. So you're not even able to speak. So
I can never figure it out. So I emailed her and
hopefully it'll work later.
Yeah.
But
okay. Well, sweet. That worked out good. Thursday, I can meet at 10 if you want to. You're good with that?
Yeah, I'm good. So we can see if that works for everyone else.
Okay, sweet.
Okay.
Thank you. Have you got the link?
Yeah, I'll stop the broadcast and then I'll post it.
Okay, perfect. Thank you.
Well, see ya.
See ya.